Good. Shall we start?
Yes.
Okay.
Sounds good.
Yeah. Happy evening to Barry Briggs joining from USA, and a happy evening to delegates from US and Canada, and a happy morning to folks in India joining from not only Chennai, even outside of Chennai as well. Pleased to welcome you all to this Spin Chennai's big video conference session with Barry Briggs, the international technology expert and a former CTO of Microsoft IT. Barry is one who lives and breathes global executive thinking around technology. There are thousands of conversations he has done with leading disruptors across tech, government, business, and education. Barry starts his address. I have the pleasant duty of doing three things. Brief intro about Spin Chennai to Barry and to those who are new. Set the context for the session today and introduce Barry. About Spin, a short of 25 years old as a knowledge ecosystem. Spin Chennai is affiliated to Carnegie Mellon Software Engineering Institute as well as ISACA, the global body. Our vision is to build a world-class knowledge ecosystem which is very compelling, highly relevant and value-adding to the people and industry, distinctively futuristic and passionately co-creative. One of the highlights of Spin is that we are always learning, we are always curious, we are always at the leading edge in terms of harnessing the latest trends. We are always tapping the global best in terms of the models, people, processes, and technology. And overall, we are like growth hackers, engaging people with conferences, Watts Humphrey Award kind of competitions to recognize the best monthly thought leadership sharing sessions, the one-day training programs, design thinking workshops, dual transformation programs, panel discussions, T-to-T sessions, paper publishing through international journal like IJATC, fireside chats, digital learning programs with management group. So many more unique things in pipeline, including sports rendezvous, process hackathons, and process hype curves. So we have a large, almost 3,000 member knowledge ecosystem comprising of CXOs, senior leaders, SVPs, VPs, HR and marketing and sales professionals, technologists, quality and delivery professionals, BFSI, telecom, automotive, manufacturing industry folks, senior consultants, mentors, academia, and other institutions. We've had several international gurus associate with Spin, including Dr. Watts Humphrey, the world famous quality guru, who has spent almost 10 years with Spin Chennai and visited Chennai several times to participate in various sessions. So in memory of whom we run every year Watts Humphrey Awards to recognize the best. Louis, which happened recently, last month. Louis Trigger from Israel, theory of constraints expert, who is a disciple of Eli Goldratt, who is the author of Theory of Constraints. We had Dr. Bill Curtis from US, who has contributed to the development of the world famous CMMI and People CMM model. Mark Johnson, who is a management thought leader and a co-founder of InnoSight from USA. He shared his insights with the Spin community about 2 months ago. Apart from leading lights from India, we had the guru of Scrum, the co-author of Scrum and Agile framework, Dr. Jeff Sutherland, speak to us about, 1.5 months ago, why 46% of Agile transformations fail. Then we had Michael Krigsman, the international columnist and CXO panelist, who was with us on a fireside chat. So, and several Indian gurus, at least 30 to 40 of them, have been part of Spin Chennai at various points in time. Coming to today's session, while the technology disruption was the main reason for the heavy churn in the S&P 500 and Fortune 2000, now we have an added dimension from the corona pandemic. This indeed has become a black swan event. CXOs the world over are facing unprecedented challenges to growth profitability, and the future strategies in the post-COVID scenario. In the absence of clear information around customer demand, product preferences, discretionary spending, etc. While cloudification, work from home, cybersecurity, collaboration, digital marketing, digital supply chain have become important themes that reduce costs and provide competitive advantage. There are several unanswered questions that CXO are pondering over, in addition to scouting for future opportunities. Even under these challenging circumstances, a few are winning in the turns with carefully devised strategies, digital mastery, and enterprise cloud strategies, etc. As a Microsoft CEO, Satya Nadella publicly observed, we have seen 2 years worth of digital transformation in 2 months, right? From remote teamwork and learning to sell and service customers to critical cloud infrastructure and security. We have all started doing this remotely, right? We started doing this. You all know how Microsoft turned around purely because one of the main reasons, the cloud division's huge success, how Satya became the CEO of Microsoft. So even Barry in his talk, he alluded to that prior to the start of this meeting. But amidst all these uncertainties in demand, cost pressures, one thing that has become clear is the need for cloud, the cloudification. Incidentally, we had a SpyCon conference, Spin International Conference in 2018, with this as one of the important themes. Here again, enterprises are brainstorming what should be the cloud strategy. Should it be a cloud native app development hereafter? If one is doing DevOps, agile methodology adoption, microservices, PaaS, SaaS, containers like Kubernetes and Docker, continuous delivery. Is that all cloud native development? Is it all, or is there more? There are a whole lot of questions around enterprise cloud strategy. How much should be private cloud? How much is public cloud leverage? Should we go full hog into public cloud and save a whole lot of costs? Where are we on security? What are the other challenges that drive the enterprise cloud strategy? What type of skill set we should really develop internally? We are looking forward to answers for most of these questions from this session. And I would encourage all attendees as well to think of all the questions and issues that you are struggling with and post them in the chat box so that we will take it up at the end of this session. We have at Spin several corporates who are not only platinum, gold, and silver members, but also several CXOs as individual members of the ecosystem. Everybody is very keen to listen to Barry today, as he has met thousands of CXOs and clearly understands the dominant thinking and direction. These are important agenda for Spin Chennai as well as its members. So without spending any more precious time, I would like to invite Barry to enlighten us through this session on cloudification strategies. But before I invite him, I have the pleasure of sharing his brief profile. Barry's profile is like an encyclopedia, right? There is so much to talk about. It's an amazing experience. He started his career in the early 1970s, right? With basic coding in BASIC. So he comes a long way in terms of hands-on and deep technology expertise. So I'm not going to read his profile, but only a few points, bullet points. He's a former chief enterprise architect, Microsoft developer experience, USA, former CTO of Microsoft IT, and led Microsoft IT's cloud strategy and migration. I think this is enough to say about him. Founder, CHARLIEDATA, implementer of cloud native big data, analytics, and machine learning applications. Author of Azure articles on cloud native computing and books such as Enterprise Cloud Strategy and Design to Disrupt, which has been published by Microsoft. He's a senior technical advisor to Accenture Chief Cloud Architect. So we are really fortunate to have him share it today with us. The format for today's masterclass session is that Barry will share his thoughts for another 45 minutes to 1 hour. That will be followed by Q&A session with the audience. since there is a chat facility available, you can post all your questions so that at the end of the session, I will have the questions related to him. So please keep your audio on mute, and only when called for, you may unmute. I have the pleasure of inviting Barry, the international tech guru, to share the tips on enterprise cloud strategy, cloud native development, and other emerging trends in the cloud area. I encourage each and every one of you to unmute at this point. Maybe I'll give 10 seconds and put your hands together to welcome Barry Briggs for his address to the Spin Chennai community.
Thank you. Pleasure.
Over to you, Barry.
Thank you very much. It's a pleasure to be here this evening for me and tomorrow morning for you. I'm Barry Briggs, and I have a couple things I'll say before I dive into the presentation. The first thing is I'm talking to you from a suburb of Seattle. And so just about 10 miles to the north of me is the corporate headquarters of Microsoft, where I spent about 13 or 14 years of my life. And about 5 miles to the west of me is the corporate headquarters of Amazon, and not too far away are the cloud operations of Oracle, Facebook, and Google. So we call ourselves here in Seattle Cloud City, and so probably no wonder that's what I'm really going to be focusing on today. It's what I've been focusing on my career on for the last 10 or 12 years or so. And the other thing I'll point out too is I actually have, as you can see on the slide, a new role. I just started as a VP of Research at Directions on Microsoft. If you're not familiar with that, Directions on Microsoft is the leading independent authority on all things Microsoft. And I urge you, if you get a moment, to check out the website, cleverly named directionsonmicrosoft.com. And with that, I'll dive in, and I'm going to start with a little bit of a history lesson. I love history. So we'll start here. We'll go back about a couple hundred years or so. And usually at this point in the presentation, I ask for a show of hands to see how many people actually recognize what this is. And obviously asking for a show of hands is not practical here, so I'll just tell you what it is. This is a replica of the world's first steam engine. It was invented by James Watt in the late 1700s when he was at the University of Glasgow in Scotland. And what's kind of interesting about it was he didn't set out to invent a steam engine. He was actually asked to repair a steam-powered pump, which pulled water out of coal mines so that coal miners wouldn't drown. Anyway, the net of it was that he did invent the steam engine, and as a result, the steam engine swept through Europe and then through the rest of the world. And as a result, it started the rapid industrialization of England and other countries. Led to the development of factories, textile mills, steamships, steam-powered locomotives. Economically, it was responsible for the increased GDP of industrialized countries. It raised the standard of living of the countries that this found itself in. And of course, there are downsides as well. Point of this is that this was really the first industrial revolution. It was really a time when the world was like this, and then suddenly changed and went to a different level. And as you know, we've been through a bunch of different industrial revolutions since the time of the steam engine. In fact, I love to show these next couple of slides because they're actually documentary evidence of the industrial revolution when it happened, another industrial revolution when it happened in this country. This is a photograph of New York City. It was taken in 1902. You'll see the famous Flatiron Building right in the center. It's right around, I think it's around 40th Street or something like that in Manhattan. And if you look very carefully at the road, what you see is all these, there are people walking across the street. There are horse-drawn carriages. Even the little trolley cars are actually being pulled by horses. And so this is a fairly, this is an animal-driven transportation society. Again, this is 1902, and it was only 30 years later. Here's the exact same place in 1933, and what a difference we see here. We have the square filled with not horses anymore, but cars. And so this is clearly a result of a massive paradigm shift that's happened within the United States during this period, and other parts of the world at roughly the same time. This mechanization of the world. We went from transportation being done by animals to the internal combustion engine. And the reason I mention all of this is, by way of historical context, is that we've been going through a series of revolutions in computing. Now, it's a little bit different for us in computing. In fact, you know, these industrial revolutions that I was talking about before, you know, they came, there was a long period between each one. For us in enterprise computing, we've actually gotten used to having a new revolution almost every few years. And it's interesting to know that, you know, our space has really only existed since the early 1960s. You know, the IBM System 360, really the first broadly adopted mainframe computer, came out in 1963, which, you know, for some of you, it might seem like a long time ago, but really wasn't all that far ago, less than a century. And you'll see kind of these, and these are totally arbitrary tiers, and there's lots of other things I could have put in here. But every few years we see this quantum change in how we do computing. And I'll just say one other thing about this, which is these things never go away. Now, for example, you know, IBM still has a great business in mainframe computing. The first mini computers came out in 1970. IBM still does a pretty good business in mini computers with the AS400 as well. The first relational database came out in 1977, which was System R from IBM, the first personal computer in 1980. And then you see various other things that have happened since. Each one of these has caused massive disruptions in how we think about doing computing, both personally as well as in the corporate environment. But this evening, or this morning, I want to spend most of my time, in fact, all of the remaining time, talking about the top 3 layers. The introduction of cloud services in around 2006, and then the next 2 layers on top of our little layer cake. So it was in 2006 or 2007, if I recall correctly, that Amazon first introduced its very first cloud services. I think, and maybe somebody else remembers this better than I, but I think it was SQS, the simple queuing service and simple notification service. I think that's right, maybe S3 as well. And I don't think anybody quite realized how significant these 2 or 3 technologies really would turn out to be. It really wasn't until a few years later when we started to think about the cloud as a virtual data center that the whole notion of cloud computing really took off. And so we had our first significant forays into cloud computing in what I call wave 1. And this is a case where CIOs believed that they could save a ton of money by moving their applications from the data centers into the cloud, what we call the virtual data center model. And you can imagine the CIO's excitement. I can get rid of physical data centers. I can get rid of servers and routers and storage, and I don't have to pay electricity bills anymore, and I don't have to worry about air conditioning, and I don't have to pay real estate taxes and all the overhead that goes along with owning physical data centers. I can just literally, and of course the phrase is lift and shift applications from my data center into the cloud. And for some people, that worked pretty well. In fact, we're still doing it today. It's like everything else that was in that layer cake, you know, they don't go away, but we build on them. And we'll talk about how we build on them in just a second. But for the moment, when we did this, we started to realize that there were some issues. And so the first issue we ran into was, well, where do you start when you think about moving to the cloud? What application do you move first? That was the hardest question of all the questions that when I talked to CIOs. The hardest one was, how do I start? Which application do I pick first? How do I build momentum? How do I build a strategy for migrating to the cloud? what criteria should we use to select applications, to select data for migration and so forth? And what most companies came up with was, it was a kind of strategy of the lowest risk first. Now, there were some that went the other way. I'll talk about that in just a second, but in essence, what you did was you started with applications that, if they failed, wouldn't bring the business down, wouldn't cause massive disruption to your business, wouldn't cause you to show up in the Wall Street Journal. And believe me, if there's one imperative that CIOs really have, although they never talk about it, is they never want to appear on the front page of the Wall Street Journal. So in Microsoft, what we did was we picked we had a charity application, an application that tracked employees' donations to charity. And what we figured was, well, if that went down or if it failed, it wouldn't actually impact Microsoft's business and wouldn't impact shareholder value in any way. So that was but it was a significant enough application that we thought it was a very good place for us to actually start. And that was the application that we picked first. And actually, we learned a lot when we first moved that application to Azure. I will say, just parenthetically, I do know of one company that took completely the opposite approach. And in this case, the CIO really wanted to make a statement that his company was moving to the cloud, full stop, period, end of story. That is our objective. And so he picked actually the most business critical applications to start with. So that's living on the edge, if you ask me, but that, as I say, they're different. Every company has its own approach. Every company has its own criteria for migration. And every company has its own definition of success. And what does that mean? So some companies will say, we want to move 100% of our applications to the cloud, 100% of our data to the cloud. Other companies take what I think is a more pragmatic approach, which is, we will move the bulk of our applications, but there may be some that we believe to be so mission critical or so sensitive that we'll keep on premise, and that's fine too. But that was really the first issue that we ran into. But then we started seeing that there are other issues that arise because of the nature of the fact that applications are in this public place, the public cloud. The first one was, well, we really have to rethink how we do security, because the physical perimeter is absolutely gone. And the more we thought about it, maybe the virtual perimeter has gone too. So we really had to think about doing defense in depth. We had to think about how we do authentication using Active Directory or Azure Active Directory. We wanted to make, in most cases for cloud applications, we wanted to implement multi-factor authentication. Companies want to implement encryption both at rest, on disk, and in transit. And now with new capabilities in Intel processors, we can actually do encryption in memory as well. But we really need to think about the whole notion of security. We need to think about how we protect against bad actors, which means we want to have AI-powered security intrusion detection, security intrusion and event management, intrusion detection, and so forth, and also do penetration testing so that we can protect against all the people who can see that public cloud and know that there's something there and want to go after it. An area I've been spending a fair amount of time on recently is the notion of regulatory compliance. And this is actually one where it's kind of been a little bit of a perfect storm in the sense that as we move to the public cloud, we've also seen an explosion of new regulations arrive. I think probably the most famous of these are the privacy regulations like GDPR, PDPR, and so forth, and that have very high penalties. GDPR in particular, I think the penalties are something like 4% of revenues. In Canada, which their parliament just passed, I think, a new privacy regulation where the penalties are 5% of revenue. So, if you get it wrong, the penalties and the embarrassment can be quite high. And of course, there are lots of other things that we rediscovered as we started moving applications to the cloud. The global reach of the cloud, it brings us to worry about makes us worry about things like, where does that data go? Does it travel over national boundaries? We have to start thinking about data sovereignty, and lots of other things as well. And finally, governance. As we started thinking about governance, who's in charge here in the IT department about deciding which applications, when do they go to the cloud? Who sets the schedule? Who's allowed to deploy apps to the cloud? how do we prevent or how do we control things like shadow IT? When we have cloud applications, especially when we have SaaS applications, all it takes is a credit card to start using them, but that can have implications for, if that SaaS application doesn't follow your enterprise standards for security and things like that. So putting in new forms of governance it has proven to be one of the things that we've had to do as we move to the cloud. But the number one issue that we ran into was what we call sticker shock. And this was quite a surprise. As we moved applications to the cloud, somehow it got more expensive. And some organizations were reporting that their applications in the cloud were as much as twice as expensive in the cloud than they were on premises. And gosh, how can that be? Because the whole point of the cloud was to really do computing, enterprise computing more efficiently. And it got so bad that some organizations, and it's a new word, repatriated their applications out of the cloud back to their data centers. And it's worth actually spending a moment to understand why that happened, because we actually experienced this a little bit at Microsoft too, where we really started to understand how cost management in the cloud actually works. So one of the hidden secrets of IT, and especially large enterprise IT, is that on-premises applications are often over-provisioned. What do we mean by that? Well, I had a friend of mine who was a CIO, and he used to tell me that whenever his app dev teams would come to him with a request for servers for an application, he would always quadruple that request. Why? Well, for example would be, I've got this new application. Please, Mr. CIO, I'd like 2 servers with, say, 32 gigs of RAM each. He would then say, okay, that's fine. I'm giving you 8 servers, and then maybe I'll give you 64 gigs or maybe even 128 gigs of memory each. And why is that? Well, most IT applications, of course, are seasonal in nature, meaning that, for example, finance applications, when is the heaviest load on them? As you approach the end of the quarter. So as you approach the end of the quarter, the CPU utilization, which is normally fairly low, suddenly spikes. And the last thing that the CIO wants is, when we're right on deadline to report earnings to Wall Street or to the government, is for all the servers that are doing the calculations to roll over. So we over-provision the servers, over-provision the applications to keep CIO mobile phones quiet on evenings, weekends, and holidays. That doesn't work in the cloud, because when you over-provision applications in the cloud, basically what you have is very expensive servers not being used. And remember, in the cloud, of course, you're paying by the hour. And so what you really want to do is optimize and right-size your deployments. And so what we found out makes a lot more sense is to, on a day-to-day basis or a week-to-week basis, just look to see how much CPU and how many resources our applications are actually using. And so it turns out maybe we can actually downsize the instance size of the applications to, smaller instances, like 4 cores and 16 gigs and 2 machines, maybe 10 months of the year, but during those last 2 weeks before the quarter end, we bump them up to larger machines and more of them, so that we and then go back down when the load goes down. And so, this actually, I do know of companies that actually create contests where the app dev leads will actually compete to, every morning they'll come in, see how their CPUs were running overnight in the last 24 hours, and then adjust the size, and they compete to see who can save the most money. But the moral of this is, and really the theme of the rest of this presentation is, it's not about using the cloud the way we used computing before. Let's use the cloud as it was intended to be used. And we'll talk, that'll be the theme of most of the rest of the presentation. Now, there's another subtle thing going on here that's kind of worth mentioning, and this is the start of a discussion we'll have on deployment patterns. But when we think about the first wave of the cloud, and like I said before, we're still in this in a lot of companies. A lot of companies still do it this way. It's fine if they're getting the kinds of benefits that they want. But we'll say that I'll say that this may not be the best way to utilize the cloud. Now, virtualization is a good thing. You can get better density on physical hardware. But if you notice, when you virtualize, when you put some number of sets of guest operating systems and applications and so forth on a particular server, you're getting a lot of operating systems in there. And each of one of those operating systems has to be maintained, it has to be patched. And there's an awful lot of code that you may not actually need when you load an entire operating system in just for a single application or a couple. And more to the point, when you boot an operating system, that can take a long time. So it's better than just bare metal, where you just have one operating system in an application, but it's still somewhat inefficient. And that's where we start thinking about, wow, how in the cloud can we take advantage of the resources that we have there to get better utilization, better speed, better performance, and better cost effectiveness. And that's when we really start to talk about cloud native computing. And the story of cloud native computing really begins with the notion of containers. And I'm sure most of you know lots about this. Of course, the term comes from the concept of shipping containers. And if you ever get a chance, it's actually fun to go back and read about the history of shipping containers. It has nothing to do with anything we're talking about this morning, but it's still a fun topic. And you'll notice over here, we have one copy of the operating system and containerized applications. And within the last 10 years or so, starting with some folks in the world of Linux and moving over into the world of Windows, a lot of folks have done a lot of great work in building the kind of levels of security and isolation that allow us to run these applications in a way that allows them to be completely secure and isolated from one another, and yet still get the kind of performance that we really want to get. And so this turns out to be a much more efficient way to run multiple applications on a single server. They boot quickly because you're not actually loading an operating system. You can go to a container registry, either the Docker registry or one that you have in your own enterprise, pull down an image and just start it up quickly. So it actually turns out to be a very rapid way of building, new applications, of testing new applications, of doing development and so on. But this is a start. This is a building block for how we think about cloud scale applications. And of course, probably the most popular way and the technology that's getting probably the most attention these days is, of course, the notion of orchestration, container orchestration, where we think about managing dozens, hundreds of thousands of container instances across hundreds or even thousands of servers. For example, Netflix uses something like, I forget how many, literally tens of thousands of servers every night running analytic applications to figure out exactly what it is you might want to watch tomorrow. Why do they run these analytics operations on AWS to find out what you might want to watch? Well, so they can ultimately download the predicted movies or predicted TV shows down across their edge network through their CDNs, and maybe save themselves some networking time and provide a better experience for you, the viewer. And it turns out that building these kinds of applications is fairly common. A lot of people need Uber and Lyft and all the ride-sharing companies, and so on ad infinitum. That it turns out that building applications at scale is something that we all need. And so these orchestration systems have become effectively cloud operating systems. And if you were to ask me 3 or 4 years ago, I'd say there's about 3 or 4 contenders for the crown: Docker Swarm, and there was Mesosphere and Rancher and a whole bunch of others. I would say today, I think we all would recognize that in terms of container orchestration, Kubernetes is the clear winner. All of the major cloud providers now have managed implementations of that: EKS on Amazon, AKS on Azure, GKE on Google, Alibaba has one, Oracle has one, and so on. So it seems clear now that Kubernetes is the dominant player in cloud orchestration, and it's a very thriving ecosystem. There are tons and tons of add-ons for Kubernetes. Things like service meshes and networking solutions and so forth, monitoring and management add-ons, so forth, which is the good news and the bad news, right? Because all these things give you a lot of power, but on the other hand, there's a lot of assembly required. It requires, frankly, far too many, I think, people to manage and maintain a large-scale Kubernetes cluster than you really should. Because remember, we're talking about deployment here. We're not talking about anything that has any real business value per se. These aren't applications where you can go back to your business and say, I got you this many more leads, or we manage this many more transactions. This is about operations, really. And by the way, this is something you probably won't get in any other technical presentation. At the bottom right is the first appearance of the word Kubernetes in history, actually. Comes from Homer's Odyssey, which is about, I don't know, something like 1200 or 1400 BC. So there it is. It's the fourth word over in Greek. And the word Kubernetes means helmsman in ancient Greek. Why they picked it, I'm not really sure. So we're seeing a lot of energy around Kubernetes. And of course, the other area where we're seeing a tremendous amount of energy now is what we call serverless. And I put in the first bullet that serverless means no more servers, and we can all laugh because of course serverless has servers, but we just eliminate the abstraction of servers. We eliminate the abstraction. We eliminate the work of having to manage servers. And in theory, at least, developers focus only on creating applications that have business value, not on what we were talking about before, which is no value infrastructure. We're still, I think, in early stages with serverless. There's been a tremendous amount of activity around it. I think we don't have to go, there's probably too much detail, but I think there's kind of a brewing architecture war in serverless between the proprietary models like Lambda and the more open models, which are based ultimately on serverless functions inside of Kubernetes containers. But these will work themselves out, and I think there's a tremendous future for this sort of thing, and for the primary reason of the second bullet, the developers are focusing on business value, and this is what our business partners want from us. They want applications that serve the needs of the business. And the last thing I'll talk about is the rise of the citizen developer. And this is something that is, I want to say it's fairly new, but it really isn't. It's actually kind of a recurring theme in our industry. And in fact, as long as I've been in it, there have been attempts to bring, to make it possible for non-programmers to write applications. For those of you with long memories, remember things like Power Builder and rapid application development tools and forms tools and so forth. And probably the most frequently used low-code, no-code application is of course Microsoft Excel. I was interested, by the way, to see a press release from Microsoft just a couple of days ago that they're adapting the formula language in Excel to make it Turing complete, which is interesting. So you basically can string formulas together and make that into a formula, and then you can have variables and loops and so forth. So that'll be interesting. What we're seeing here on the right hand side is just an example. This is Microsoft Power Automate. It's a workflow program that is supported by Azure. We get things like forms, applications, data access, workflows, and so forth. The real question with these sorts of things is, can these citizens developers really relieve the IT burden? Can they take work items off of the IT backlog and do some things on their own? And if so, where are the boundaries? And when is it possible? When is it the case that the citizen developer will run into trouble and potentially mess up some of the systems that are in IT. For example, what happens when a non-technical person starts writing applications that potentially corrupt business critical data? You know, how do we in IT protect them and provide them with certified data? And when do they get in trouble? When the application simply becomes too complex for them to build, or too complex for them to maintain, or too expensive for them to maintain, and then they ask IT to come, please come take this over for me. And this happens all the time. Happens all the time. It also happens, by the way, with SaaS applications and other cloud applications that people buy. You know, as the dependence by a business unit grows on these types of applications, you know, eventually they become too expensive, or they become insecure, or they fail some sort of audit, and they have to be moved over to IT. So it's incumbent upon IT to the extent possible, keep an eye on these things and be aware of when these sorts of things are likely to come over to IT. I will say in parentheses, I think that it's large. You know, there's always this movement among IT professionals to try to eliminate shadow IT, and find it and eliminate it, crush it, stomp it out like whack-a-mole or what have you. My view is that that's impossible. And I think that the more realistic solution is, to the extent possible, provide the sandboxes and the guardrails, so that when citizen developers are writing their applications, they do it safely and in a way that doesn't in any way damage the ecosystem of IT applications and data. So we've talked a lot about sort of the models for deployment, but I want to spend a few minutes talking about the stack. You know, the application stack. And this is something that's undergone an enormous amount of evolution in a very, very short period of time. So we're going to talk about application I just love this picture of Florence. We're going to talk about application architecture for just a second. So not so long ago, and this is another one of those moments when I'd ask people to raise their hands, if you remember the three-tier enterprise application architecture, architecture. And you know, we would talk about, you know, the presentation layer, which was, you know, maybe WinForms, or maybe HTML, or maybe a thick Java client, or what have you. And then there'd be a stateless middle tier of C# and Java, WebSphere. By the way, I have to tell you, this is a complete digression. The first time I met Satya Nadella, he talked about, or actually, this was the first time I heard Satya talk when he was CEO of Microsoft. And as CEO of Microsoft, he was talking about you know, how we build stateless middle tiers, and I just thought that was great. That's great. A CEO of Microsoft talking about stateless middle tiers, excellent. He gets it. He gets it. Anyway, so and these things would be typically built in C# or Java, or maybe use a package like IBM's WebSphere or SAP's NetWeaver or what have you. And then there'd be a relational database on the back end. And it turns out the three-tier model for applications is pretty well known and pretty famous. Less famous is what I would call the canonical data architecture in about 15 years ago or so. It has 4 layers where we have master data at the bottom, so the authoritative sources for things like customer data and product data. Transactional data, which changes very quickly. This is the data that gets stored by transactions. All this data would flow upwards into a data warehouse where it would be consolidated. And then that would be sliced and diced and put into marts. And as you can see, data typically always flows upward in this model. And so the great thing about these two models for enterprise application architecture and enterprise data architecture is that as developers, as IT professionals, we knew what we had to build. That was great. We had an idealized architecture. Of course, the problem was we never built these things. We never built applications this way, or hardly ever built applications this way. Why? Well, you know, it's not because we were lazy. We worked pretty hard in IT, but and I don't mean any one company. I mean broadly across all companies' IT. it's not because we were lazy or anything like that or inelegant. It was, there are a lot of actually, while this is an elegant set of architectures, they're actually fairly hard to build. For example, if you set out to build a 3-tier enterprise application, that means you need 3 separate skill sets. You need a team that understands how to build HTML on the front end or WinForms on the client side. You need UI developers. You need teams that understand C# or Java or what have you for the middle tier, and you need relational database SQL programmers for the back end. And so what happened more often than not with these is that you would actually skip the middle tier and have a presentation layer talking to stored procedures and so forth on the back end. But anyway, it was a good thing that we knew this was the model. Now, what we're going to say in the next few slides is this has largely been made obsolete, but it's worth remembering because some of the principles behind this are still pretty valid. Hello? Now, well, anyway, now we're into the cloud mode, and you know what used to be very simple, a bunch of blocks and layered up in a stack, is no longer at all simple. We have an exploding tsunami, if that's a word, if that's a phrase, a tsunami of new technologies. I don't know how many of you have been watching AWS reInvent over the last few days, or last week or so. You know, we get new technologies practically every day, you know, not only from the cloud providers like Azure and AWS, but also from, you know, any number of independent software vendors, startups like you have in Chennai, and all over the world. And so all over the world, in fact. And so, you know, it's difficult to know, you know, if you're an architect, you know, if you're building an application, well, what should I do? Well, that's a hard question to answer, but let's take a crack at it at least. So I want to give you a story, and this really happened about 4 or 5 years ago. I was at a hackathon with some customers and some folks, and there was some folks that were doing an IoT application. They'd invented a little device, those little black boxes on the left, device 1, device 2, and so forth. And it could either talk REST to a web server or go through a home PC or an Xbox to the server. And the web server, you know, managed the device traffic, and it would occasionally write to a log. I think it was in SQL Server or maybe MySQL, I'm not sure. And from time to time, they would do reporting. And they were very proud of this application because, you know, one of the things that when you're in a startup, and I've been in many, one of the things that you're really always pleased about is the fact that it actually works after all this hard work that you put into it. However, you know, we had a kind of an enlightening conversation where I asked them a bunch of questions about this architecture and about where they were going with all of this. And I said, well, you know, is this going to work, you know, when you're very successful and you have 100,000 of these devices out there, or maybe even several million of these devices? What about if you want to keep track of what these things are doing, and you'd like to sort of get a sense of, you know, if one is likely to fail anytime soon, or you want to see what customers are actually doing with them and what they're not doing, what are the customers finding difficult with them, and so on. You know, do they want, you know, are you getting the best value for your money by using something as heavy as HTTP and REST to communicate with the web server and so on? And so I said, you know, I really need to think about, you know, whether this is really the right long-term architecture for how you think about building your startup. So, you know, what happens if you want to catch exceptions in real time? If you want to catch combinations in real time, do some streaming analytics and combinatorial things. You know, maybe you should think about not using HTTP and maybe use something else like AMQP or MQTT or WebSockets as examples of things that are not quite as heavyweight as HTTP. And maybe you don't want to write your own reports. Maybe you know, there are opportunities to do something with existing reporting capabilities. And what happens, you know, when you need to ship quickly and repeatedly, and not do as we used to every 2 years or every year or even every 6 months, but daily. And so what we did was we came up with an architecture that looks something like this, where they could use where they could have lots and lots of devices, have concentrators out in front of them, where we would use, instead of using just a web server, we use Azure's Event Hub, which would scale massively. We could use the Azure Service Bus in this case to send commands back to respond to the devices. We'd store data in blobs or NoSQL databases. We could then take that data and stuff it in other places, like through streaming analytics, to do interesting sorts of real-time analysis of what's going on out there. We could have agents to actually monitor each device independently. We could take this data and put it into a big data repository, like in this case, it was HD Insight, or Spark, or Azure Synapse, or DynamoDB, or what have you. Don't want to be too Microsoft centric on all of this. And then maybe from that, we can run experiments to see, gosh, given this combination of events and this combination of messages they're receiving, is the device potentially likely to fail? And is there something that we can actually do to inform the user that, gosh, we need to send out a service rep, or you need to replace your device before it fails, because based on our predictions. And we could then use one of the various networking technologies like a VNet or a dedicated line like ExpressRoute or Direct Connect to send information back to an on-premises data warehouse and or our ERP system for financial reporting. And so what you see is you start to see that we can very easily, and all these things are available with just a few clicks, as many of you know, to actually expand the notion of the stack that we had before, so that it's this mass of interconnected and cooperating services that you simply need to just wire together. And so with not much work, suddenly that very simple application that we had before becomes a very, very sophisticated one. And without too much trouble, we can actually connect it to one of the dashboarding applications and reporting application, and actually see on a real-time basis what's going on out there in a very nice graphical format. This happens to be Power BI, but it could just as well be Tableau or one of the other similar tools. And so when we think about it, what does all this mean? It means that we've gone from a model where IT departments used to buy or write all their software to a model where you can just buy these, you just connect to these managed services in the cloud. It means that the 3-tier architecture model is really in the cloud is kind of over. It's easy to add all these new capabilities, new tiers and so forth. In fact, the very definition of an application has really substantially changed from how we think about it, or how we used to think about it 15 or 20 years ago. And I'll talk about this in a minute a little bit more, but the risk of trying and acquiring new technologies has radically decreased. And that's a really, really big deal. And I'll talk about that in just a second. And this slide just kind of reinforces what I said before, but the notion is really that it's just these interconnecting services that that loop back to one another, where we have data from all sorts of different sources, external government streaming data, transactional systems flowing into warehouses, lakes, NoSQL databases with lots and lots of different interfaces to control them and so forth. So again, the conclusion, at least the conclusion I draw from this, and your mileage may vary, but my conclusion is the whole notion of an application stack is really, it's either gone altogether or has changed so much that it may not even be worth using the phrase anymore. So I'd say something a little bit about risk. And when I talk about risk, I mean the risk of bringing new technology into IT. What do I mean by that? This isn't one of those subtle implications of cloud computing that isn't really that obvious to start with, but in fact is profound. In the old days, hardware and software are expensive. They cost a lot. I mean, those boxes on the right-hand side, that's an IBM mainframe. That's millions of dollars of equipment. And so, if you're the person that's making decision about buying it, you better get it right. And so to get it, make sure that you got it right, you go through this long process of writing requirements documents, doing requirements investigations, doing functional specifications, And then once you had the hardware and software in-house, you do betas and user acceptance tests and all kinds of things. And this, of course, annoyed the heck out of the business and of our business users, because they saw IT as being too big, too slow, and too expensive. But if you got it wrong, you know, there's millions of dollars on the line and probably, you know, your job. So you wanted to get it right. Whoop. And hang on, that's what happens when I hit the wrong button. We'll get there. Sorry about this. Pay no attention to the man behind the curtain. There we go. But today, ignore the last 30 seconds. Today, experimentation is a great way to reduce this. You can actually just take, because the cloud is a pay-as-you-go model, you can just take cloud services out for a spin. It's a great way to build knowledge. It's a great way to build employee engagement. And so if I think about, you know, I can actually tell you a story about this. There was a customer that I'm aware of that was spending something like $30,000 a month for SQL Server licenses, or maybe $40,000 a month on SQL Server licenses. And in a hackathon, we tried out with them, you know, why don't you try putting this data into Cosmos DB, which is much cheaper. It's not as transactional relational database like SQL Server is, but in this case, their data was historical and not something that we think about, you know, doing massive rollbacks on or massive updates on. So Cosmos was actually a pretty good choice. Net of it was that their costs by moving out of SQL Server and into Cosmos was they actually managed to recoup 90% of their investment. So here's the thing. If you can tell your business that they can have, in this case, I think $3 or $4 million back every year, you're going to be a hero to them. They're going to like you an awful lot. So, and if it doesn't work, you've still learned something. You haven't invested a huge amount of money. You've just rented the software, the services for, you know, maybe a week or over a weekend or something like that. And just a little caveat is if you do something like that and you put company data in, make sure you clear it. So just to start, we're running out of time. So, and that's good because we're just about done. The cloud offers great promise. And, you know, I know I sound like sort of like an evangelist here. There are issues. And there are challenges. You need to, you know, your folks need to learn new skill sets. Probably the most underrated of all those is learning how to do asynchronous programming, you know, to get the most out of your scale if you're building an application. You know, asynchronous programming means if you're calling out to a service in another server or another machine or another cloud even, you know, you want to suspend and let another application run in its place or another thread run in its place. This is the task await model in many programming languages. We talked a little bit about shadow IT and the importance of governance, and you know, GRC, the governance, risk, and compliance, and of course security are super, super important. It raises the level of vigilance that you have to have as a security professional, as a cybersecurity person. But the great thing about this is we're certainly not done with all the revolutions that are going to come. That's, of course, for many of us, if we're in this industry, that's why we're in this industry, because there's always something new. So multi-cloud computing, of course, you know, there are, you know, using services out of AWS and Azure and Google and Alibaba together, maybe to use the best of breed from different vendors, or maybe for failover purposes, to fail over from one cloud to another. There are regulations in certain countries where financial organizations have to be able to fail over their entire ecosystem from one cloud to another. So these are challenging things. Edge computing, of course, where we need guaranteed connectivity and fixed latency. So bringing cloud computing out of the cloud and into your own location. And this is actually kind of interesting because in the beginning we used to think about extending from the data center to the cloud. So we would make calls out of data center applications into cloud services. This is going the other way now. This is the cloud coming back down into the data center. I often refer to it as the phase two of hybrid cloud, where phase one was sort of this old model of reaching from the data center out to the cloud. And there's lots of new technological innovations going on. Quantum computing is one of the most interesting of all of those, taking advantage of quantum mechanics and quantum mechanical operations to be able to solve problems that we never could before, that it would take, you know, tens of thousands or even millions of years on classical computers. But there are other things that are quite somewhat less exotic, and we saw Apple release its new M1 processor. We've seen the new data processing unit from NVIDIA result of their acquisition of ARM and so forth. So lots of great things coming down the wire. So where does that leave you? And I often say that if you're in IT, you've got three forces on you at all times. And those are, you know, you've got the pressure to disrupt, to take advantage of all these new technologies, to implement new business models. You've still got to keep the old ones running and keep them running better. And you've got to comply with all the different regulation standards and policies that you have. So you all have hard jobs. You do, and I appreciate that. And this, I'll close with this slide. So if you want to make it better, then make it better. The best way to predict the future is to invent it. This, Alan Kay said this in 1971. It was true then, and it's true now, and we've seen it all. We've seen it happen. And with that, I want to thank you for your time. And if there are any questions, I'll be happy to answer them.
Fantastic presentation, Barry. Very, very insightful. So maybe there are a few questions. The first one I would like to start with is you designed the enterprise cloud strategy for Microsoft. That must have been a big challenge. See, Microsoft being a behemoth with so many products, so many services. You know, how did you design? How much of it is private cloud, public cloud? I am assuming everything is on Azure. So
Yeah.
can you throw some light on some of the.
Well, so the first thing that we did, it's a great question. The first thing that we did was we stepped back and we looked at the kind of the scope of the problem. And what we realized very early on was that the transition to the cloud was not purely a technological issue. You know, there was a big part of it. You know, a lot of times, you know, if you get in a new database or you get in a new application or something, you know, your business partners will say, that's just an IT thing. Don't worry about it. Don't bother me with that. But we realized with the cloud, it has significant implications across a wide variety of functions, not only among the technical staff, but among other organizations as well. So for example, obviously the technical staff, obviously I think, you know, in very short order, we recognized that the cybersecurity teams had to be involved, that the compliance teams had to be involved, but also the finance teams as well, because we're changing the way we finance IT. We're going from a capital expense model where we buy servers once every 3 years or so, let them depreciate, to a model where finance had to be involved literally every single day. We had to involve HR because we had to train people, and we're changing job functions, we're changing career ladders and so forth. And so, you know, there were functions that suddenly didn't exist anymore as we started moving to the cloud. So first thing we did was we built this cloud strategy team, which met pretty regularly, to figure out what it is, you know, to figure out what it is we actually had to do, what each individual organization had to do, and to sync all those up to make sure that we were on track. And then the next thing we had to do was kind of build the roadmap of where we wanted to go. And the free piece of advice that I give everybody on this topic is when you're building a roadmap, you need to know where you're at to start with and where you want to end up with. And then you kind of back solve from that. So knowing what your destination is very, very important. So how do you know you're done? But equally important to that is knowing where you are. So one of the things that we had to do was have a very crisp understanding of, you know, what applications we actually had and what were their characteristics. You know, for example, how big were the servers? What operating systems were they running on? You know, how much storage did they use? How interconnected were they? How business critical were they, and so forth. And from there, what we did was we assigned what we called a cloud lead to each IT organization. So HR IT and finance IT and legal IT, each one of those IT organizations had a person who was responsible for building the roadmap and the schedule for how applications were to move to the cloud. And then we had this master plan that we would use to actually deploy to the cloud.
Fantastic. So the key driver even today, is it only the cost aspect, or do you feel it has moved on to much greater things?
That's a great point. And, of course, cost is always a significant aspect of that. But the other thing, too, is I think is that the cloud enables you to implement new business models. And so I sort of alluded to this a little bit during the talk, but let me hit it a little bit more distinctly now. A number of cases where, good example is, I think it was Rolls-Royce. They make jet engines, among other things. Also nice cars too, by the way, but they make jet engines is the example I use here. And what they do is they collect data from their engines. They actually have a hard drive on the plane. And I think it's like 500 gigs from every flight that they collect telemetry from the jet engine. And once the plane lands, they upload all that data from the cloud, to the cloud rather. And what's interesting about that is that then they can then go and run predictive analytics on that and be able to forecast a problem that might be nascent in that jet engine. But what they can then do, they can then send out a service person to fix the jet engine before anything happens, before there's an outage, before there's the engine has to be repaired and the plane taken out of service. And there are lots of examples like that. There are air conditioning companies and so forth that now put telemetry on building air conditioners and so forth. And again, it can proactively detect faults. But what's interesting about that then is once you've done that, then you can change your entire business model. Now you're not selling jet engines, you're not selling air conditioners, you're selling a service. And having the jet engine becomes a subscription service for the customer, for the airline. And so every month the airline sends them a big wad of cash, but in return for that, they get guaranteed uptime. And that's a great bargain for both sides. It's a win-win for both sides of the scenario. So you've got this new kind of model where it's where physical objects are now becoming services that are being provided, and monthly subscriptions, and you get guaranteed functionality. So that's a case where I don't know that we could have predicted it in advance, but we're seeing entire corporate business models actually changing as a result of the cloud.
Yeah, interesting. Dinesh Ganesan is asking a question. There are a lot of concerns on security on the cloud, especially with zero trust being the norm. What is your take on security on the cloud?
Well, I think you hit on it. I think it's vitally important that everybody think about security in the cloud as being a zero trust model. And I think that that means a whole bunch of things. That means every device that talks to the cloud has to be hardened. So there's lots of things like mobile device management to make sure that the devices have the latest patches, the latest security, latest antivirus, and so forth. There's a whole variety of techniques of ranging from encryption to putting keys into hardware appliances called HSMs and so forth. And then you having a very active information security function that do things like intrusion detection and penetration testing and so forth, to constantly be on guard for the sorts of attacks that are likely to happen these days. And you have entire countries now that are devoted to that have large teams of very intelligent people that are devoted to hacking into systems. So it's vitally important that you do these things. I have to tell you one other story about this, though. I was talking to one customer a while back. It was a large pharmaceutical company, and he was telling me about how they were putting in the U.S. they call them new drug applications, and it's a very, very long document that describes how a new drug is, what it's made out of, how it's intended to be tested, and so forth. And it's a ton of confidential and proprietary information. And he wanted to put it up in the cloud. And this was still kind of in the early days of the cloud. And I said, wow, you don't have any concerns about, security of putting this very sensitive data up in the cloud. And he says, are you kidding? He says, you guys, meaning at that time, us at Microsoft, he says, you guys love this stuff. You live and breathe security. I would rather not have to pay, lots and lots of people for a job that I know you guys can do better than we can. So, I thought that was kind of an interesting perspective.
Yeah, another question that has come up is, with most of the offerings on cloud, is not the role of CIO being made redundant with even a CMO or COO or CDO can take technology-related decisions, as most of the applications are on a SaaS model.
Sorry, I missed part of that. Could you repeat the question?
Yeah, see, with most of the applications on a SaaS platform, the role of CIO being made redundant.
That's a good question. I don't know. I think the role of the CIO is definitely evolving, and I think that a lot of companies, Microsoft included, has actually removed the notion, the actual title of CIO, and made it Chief Digital Officer, which I think is appropriate. But I will say this, that there will always 100% of the time be a requirement by some group of professionals to maintain the security of enterprise data, to ensure that systems are patched and up to date, to ensure that unauthorized people are not getting at the data, to make sure that the data is protected, to make sure the right technologies are being deployed to ensure compliance. For example, things like document retention and document sensitivity labeling and things like that. There will always be a need for an IT department, and there will always be a need for someone to run an IT department, whether it's called that or not. That makes sense?
Yeah. Another question is, what Thiru asked this question: what is your suggestion experience in introspecting apps on cloud? Introspecting apps on cloud to optimize them better when one wants to validate the intended to be used.
Well, so I guess the question is, how do we introspect applications on the cloud?
Correct.
Is the question defined, is it about understanding if they're being used as we want them to be used, or is the question about, are we getting the most for our money with the cloud? Because certainly
what they were intended to be used.
That's a very interesting question. I think that there's a lot of different things that we can do by monitoring, for example, how APIs are being used, and by using algorithms that will help us to elucidate what the user intention was. I think that's an interesting question, though. I think that that's something that we're probably in the early stages of. I'd like to know more about what the requirement is, actually, because is the idea that we want to know, are people misusing applications? Are people maliciously using applications? Or is the application built badly and we need to go back and recode it because it's too hard to use?
Thiru, you can unmute and share your thoughts.
Yeah, that's a really interesting question.
Yeah, thanks, Barry. So the question, arised because, most of the application, because everyone in the organization wants to get onto the cloudification, right? Most of the companies, they simply, get by the movement of cloudification, right? But as you rightly point out at the beginning, not necessarily, they could evaluate a trade-off between their existing server setup model and their cloud, right? And after when they, as you rightly mentioned at the beginning again, right, after getting onto the cloud, if they introspect, the charge would be more, right? Some of the, if you look at any big organization, multiple platforms and applications within their organization, their business capabilities and functions, each of those specific units itself may cost like, millions and billions, right? So that's where I would like to, keen to understand, is there any empirical formula or any kind of way to introspect those application in terms of all the, you know, the setup that is available there, right? Be it at the data layer, be it at the you know, the application layer, to see when we scale up the application, are we still using to the you know, are we 100% utilizing those setup, or is it like, you know, we just simply procure but we are not actually needing that kind of you know, scale up? So so that's the thought here to understand better from you.
Yeah, I'd say that, you know, we're still in the early stages of being able to do that sort of thing. And in fact, you know, I've heard the advice given, you can't know how much your application is going to cost in the cloud till you actually run it in the cloud. And then what you do is you kind of tweak it to get the optimal use out of that. And I think there's a certain amount of truth to that. And there's a lot of things you can do with, you know, monitoring and that sort of thing to determine what the performance characteristics and what the cost characteristics of an application are. But I think there's a deeper question that you're asking as well, or it's implied by your question, which is knowing, you know, if I do a capability model of the application, do I know, you know, which capabilities are being appropriately used, and, you know, are those capabilities being scaled up appropriately, and are they being duplicated, you know, amongst different applications in the cloud where this could cost a lot of money? And the answer I give to that question is that, you know, enterprise architecture still matters. You know, and when I think about enterprise architecture, and I used to run the enterprise architecture group at Microsoft, you know, I think about, you know, things like, you know, doing analysis, you know, doing static analysis of capability modeling and making sure that, you know, the applications that I have are actually most efficiently deployed, or most efficiently implementing, I should say, the capabilities that we need. So we did one analysis where we looked through all of our applications. This was, gosh, 10 or 15 years ago. We discovered, for example, we had 4 or 5 different applications, all of which were doing, I think, lead management. It was one of the capabilities. I'm not sure if that's right or not. And we realized, you know, that's something that you can't really fix with any other way other than change management, which isn't quite as clean as a technological approach. So, you know, but you know, it has its reward. So, you know, the net of it is that, you know, enterprise architecture is still a useful function, and I highly recommend it.
Thank you, Barry.
Yeah, moving on. Chandrananda Kumar of Infosys is asking a question: how to convince clients to adopt public cloud for a SaaS player who wants to shift from on-premise to public cloud completely?
Well, I think you know, the story of thinking about moving from on-premises to, especially to a SaaS provider, is a really good story. You know, in terms of, particularly in terms of cost, because and in terms of efficiency, because, you know, you're probably moving from the least efficient, both in terms of cost, operations, and management, and people-intensive approach, to the most efficient approach as you move to a SaaS model. You know, where typically you're charged by seat. You know, and the great thing is you don't have to have any IT staff to run a SaaS application, or very few, actually, considerably fewer, and I'll talk about why in a second. But, you know, the point is, you know, you're suddenly radically decreasing the footprint of people that you have on premises to, you know, when you move to SaaS. Now, of course, you may have some people that, you know, a lot of people think that moving to a SaaS application is very straightforward because it's just a simple thing, and, you know, it's a standalone application. But in the real world, of course, the SaaS application is just one of many that's in your IT ecosystem. So you still have to build integrations of one form or another. You know, but still, the point is that that's a much smaller and more tractable task than actually maintaining a whole suite of applications on premises.
So it is like almost server to server copy from on-premise to cloud. Yeah, well, I mean, I think, you know, we used to have like a kind of this, you know, the going from the least efficient to the most efficient. You know, the least efficient was on premises. The next least efficient was IaaS or lift and shift. You know, the next level was platform as a service, because at least then you didn't have to use update operating systems and system software and so forth. And then the most efficient is a SaaS application.
Yeah. So Rajaram, if I could ask a follow-up
Yeah, sure.
question. Yeah.
Sure.
So Barry, again, great presentation. Thank you. My question was slightly different. Say, for example, a SaaS application was thousands of clients, but the SaaS player themselves have invested completely on-prem, right? And they want to move to public cloud, but they have sticky contracts where each of the clients already onboarded want to make sure that the data resides on-prem, not necessarily on public cloud. So how do we, if the SaaS player wants to migrate to public cloud completely, but he has already contracts with those clients who are already onboarded to stick to on-prem. So how do we convince them in this kind of a use case? That was my question, actually.
I see. So let me play that back to you because I want to make sure that I understand. So the data, so there's a SaaS player. Sorry, I may have this wrong. So there's a SaaS application, and he wants to move stuff off of on-premise, but the customers still have lots and lots of data on premises, and they would rather not move it off, and they have contracts to keep it on premise for a while.
Yeah, that's right. Yeah.
Okay. Well, there's a couple ways to, a couple ways to think about that, which, you could think about, for example, this is a suboptimal approach, but you can think about multi-mastering the data. So, setting up a synchronous, data exchange between the on-premises data and data in the SaaS provider as one example. Or you could set up, nightly, event-driven, ETL from on-prem to the SaaS provider. So, if you're using the applications on-premise, you update it on-premise. If you're using the application in SaaS, and then they essentially reflect back to one another. I mean, there's I don't think there are elegant ways to solve that problem, but there are ways to solve the problem.
Okay, thank you.
Yep.
Yeah, before taking up one or two more serious questions, one lighter question, Barry. See,
Yeah.
you've been at the top echelons of Microsoft, interacting with Bill Gates, Steve Ballmer, Satya Nadella. Can you share some moments with them? What kind of?
Well, sure. I mean, I think the interesting thing about that is I think it's been my privilege in the software industry, and I've been in it for a long time to meet and work with a number of the leading personalities. Not just Bill and Steve and Satya, but also I worked with Steve Jobs on a couple projects, and Lou Gerstner, who was the chair of IBM, and so forth. And here's my wisdom that I've learned from all of those guys is that the choice of CEO is a very, very important one for a company, because in many ways the CEO and the CEO's personality and the CEO's whole worldview permeates down through the whole rest of the company. So, Steve Jobs, I would say, what he fundamentally wanted from his teams was a device that he himself personally would use, and he wanted it to be simple and straightforward and easy, and be a model of ease of use, and that's what led to the iPod and subsequently the iPhone. But it was all about just how simple can you make this device, and how elegant can you make this device. Lou Gerstner at IBM was a very different person. He understood the power of a large bureaucracy. At the time, IBM had something like 300,000 people, and I was working for a company called Lotus Development at the time, writing spreadsheet applications, and IBM bought us. And I met with Lou a few times, and Lou fully understood that with the numbers of people that he had, that he could apply change on an absolutely massive scale throughout the world. So, he would talk about, how IBM as a corporation was at the time, they were, basically wiring up entire countries. China was the one at the time that he mentioned. So, it was a matter of being able to manipulate a large organization to accomplish great things. Bill likes to solve really, really hard problems and have lots of really, really smart people around him. And Satya, I think Satya more than almost anybody really gets the notion of I think he takes real joy in software, and I think that's what's a pleasure. He takes joy and he loves software, and he loves software development, and he loves software developers, and you really see that come through in his speeches and in his talking and so forth. And I think that's really led to just a real rejuvenation of Microsoft. I think it rejuvenated and accelerated Microsoft's investment in cloud. And I think it's led to Microsoft's really tremendous trajectory over the last couple of years.
Oh, fantastic! Very good. So yeah, maybe one last question. So how does the cloud strategy impact the enterprise strategy?
What a great question. Great question, and great question to end up with. And I would say that, we talked about this a lot in our book, Designed to Disrupt. And it really, the realization that we had is, we all talk about digital transformation and, how digitizing changes the company. And, I would say the core element of digitization is, of course, the cloud, because it gives you the global reach. It gives you access to all these services. It just enables so much at such a low cost that it enables you to do things. And, talked about before, it enables entirely new and totally innovative business models. I mean, the amount of innovation that we've seen in the last 10 years far surpasses what we've seen in the last 20 or 30, 20 years combined. So, I think that, more and more, as I mentioned before, see the role of CIO changing to the role of Chief Digital Officer. In fact, one of my friends tells a story. Who was a CIO of Microsoft, in fact, and he said as they moved through the changes of digital transformation, suddenly he was no longer being measured on uptime of applications, which is the traditional measure for a CIO. Now he's being measured on how many leads he provides to the marketing team. And it's a profound change, because he's being measured now in business terms, not in technical terms. And I think that's kind of profound from the standpoint of this is what it really means to digitally transform, that the IT department really becomes not just a partner to the business, but part of the business. In fact, drives the business. And another story I'll tell, and then I'll close. There's a story that somebody told me from another company, but he said, there was a group that did financial reports, that built financial reports for the finance department, and these reports would take a week on premises to build, with lots of marts, lots of joins, and lots of complex queries and aggregations and blah 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 blah. It would take about a week to generate this report, and they suddenly realized that if they added more servers, which is easy to do in the cloud, you just add more capacity, they could actually deliver that same report in a matter of hours instead of in a matter of days. And that led to an entirely new conversation between the IT and business. So no longer was IT demanding, I need X million dollars for servers, but it was, how soon do you need this report? The sooner you need this report, the more it's going to cost you. But if you don't need it so much, it isn't going to cost you as much. And it's a totally different level of conversation with the business. So I would say that the cloud and all the implications of the cloud dramatically transform every aspect of the business.
Thanks a lot, Barry. I think it's a very, very insightful presentation. So I would like to, and that too, it is very late in the night for you. We have slightly overstepped on the timeline. I would like to invite Raghav to deliver the vote of thanks.
Thanks, sir. Thanks, Barry, and people on call. Barry has been a coder, hands-on coder for the last 50 years. It is not just 1 or 10 years or 20 years. He has been a coder for the last 50 years. And he started coding even before graduation. That's what he said. When he was in his high school, when he was 16 years old, he started coding. And then we were internally discussing who should we call if we have to do a session on cloud. It is the latest trend. And then we just thought, okay, let us go to Microsoft people. So then we found Barry is the right person, and then who actually navigated the different technologies, and you might have noticed the tech intensity of his talk. Being a hands-on coder, we might understand how technically he was into all those things. And then once again, I would like to thank you, Barry, for covering how to start, where to start, how to migrate, and the new tech stack, and then covering the latest trends such as quantum computing, multi-cloud strategy, all those things, and then uh, and the new frontiers, you call it, and the rise of citizen developers. And thank you so much for joining all the way from Seattle. I know it is 10 o'clock the night. Thank you so much once again for
My pleasure. I enjoyed it. It was great chatting with all of you. Thank you for inviting me.
we would like to meet you in person in Chennai as well.
Let's hope that's real soon.
Sure. Probably next year.
Yep, let's hope so.
Yeah. Thank you.
Thank you all.
Thank you, everyone. Thanks, participants.
Good morning to you all, and good night from Seattle.
Thank you.
Thank you, Barry. Thank you so much.
Thank you, Barry. Thanks, Rajaram.
Thank you, guys.
Thank you.